the note packet here for 4.2. There's some background information. It says there's something comforting in the repetition of some of nature's patterns. The ocean level at a beach varies between high and low tide approximately every 12 hours. The number of hours of daylight The number of hours of daylight oscillates from a maximum on the summer solstice, June 21st, to a minimum on the winter solstice, December 21st. Then it increases to the same maximum the following June 21st. Some believe that cycles called biorhythms represent physical, emotional, and intellectual aspects of our lives. In this chapter, we're going to look at the 6 trigonometric functions that are used to model phenomena that occur again and again. So the word trigonometry means measurement of triangles. Trigonometric functions with domains consisting of sets of angles were first defined using right triangles. By contrast, problems in calculus are solved using functions whose domains are the set of real numbers. Therefore, we introduced the trigonometric functions using unit circles and radians rather than right triangles and degrees. So what I'd like you to do is we're going to draw a unit circle here, just a nice small one. And the reason why it's called a unit circle is that the radius is 1 unit. And then we're going to go ahead and draw a point, x comma y, and it's going to have a radius of 1 unit. If it is the point x comma y, you go to the right x and up y. And what I want you to notice is that if I do SOHCAHTOA, sine of theta is y over 1, which is y. Cosine theta in SOHCAHTOA is x over 1, which would reduce to just x. And then watch this. Tangent theta, TOA, is opposite over adjacent, which is y over x, but that's sine theta over cosine theta. So you need to put that in your math tool belts, okay? That tangent theta is sine theta over cosine theta. Also, for your math tool belt, is that x comma y is always cosine theta, comma, sine theta. Okay, these are important pieces of information. And I am acting on the assumption that you've done some work with trigonometry last year. We can define the 6 trig functions. So we did sine theta, you know, was opposite over hypotenuse. And then it has a reciprocal of cosecant, which is hypotenuse over opposite. Cosine theta from SOHCAHTOA is adjacent over hypotenuse. Does anybody remember what was cosine's reciprocal? Secant. So this is secant theta would be hypotenuse over adjacent. Tangent theta, TOA, is, again, opposite over adjacent. So its reciprocal cotangent is adjacent over opposite. And what I have in the table below is sine, S-I-N-E. We abbreviated S-I-N, but we don't call it sin, we call it sine. Likewise with cosine, we don't say cos or cos, we say cosine. All right, hopefully you received a yellow circle. What I would like you to do is take the yellow circle, and I'd like you to fold it in half, and then fold it in half again, and kind of crease it. And then I'd like you to open it and use your writing utensil and draw coordinate axes where you have folded. Okay, so take the yellow circle and you have just folded and made 2 quarters, or excuse me, 4 quarters. And what I'd like you to do, we're just going to do a few of these because we'll do the whole thing on the back. If I have 0 degrees, that's 0 radians. I have 90 degrees, pi over 2. So go ahead, once you get your coordinate grid drawn, okay, once you get your coordinate grid drawn, I want you to label the 4 areas. So 0 degrees, comma, 0 radians, 90 degrees, pi over 2 up at the top, 180 degrees, pi, 270 degrees, 3 pi over 2. When you're ready, I want you to go back and double fold like you did, and then I want you to fold it again in half. So it's going to look like a piece of pie, maybe?
Slice of pizza.
Yeah. So then I want you to open it back up. Okay, so you fold your 2 original and then fold that in half. So yeah, piece of pizza. Good. Then crease it and then unfold it. Then this is going to go 45 degrees, pi over 4, and draw lines through it. And then what's interesting, as you go around the circle, you get your pi over 4s. So you're going to get pi over 4, 45 degrees. This is 3 pi over 4, 135 degrees. Then we're going to go to 225 and 5 pi over 4. And then 315 degrees, 7 pi over 4. And what I told my Algebra 2 students last year is when you think about this, your pi over 4s, they're odd. It's pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. The reason why you see the odds is that the evens reduced. Like this really is up at 90, 2 pi over 4, which reduced to pi over 2. And this one's 4 pi over 4, which reduced to pi, and so on. All right, so when you're ready, let's go back to the note packet. And so this is my 0 degrees and 0 radians, and it's the point 1 comma 0. So this was 45 degrees, pi over 4. This one's 90 degrees, pi over 2, and I know that's 0, 1. This is 3 pi over 4, 135 degrees. This is pi, 180, negative 1, 0. These are the halfway marks, okay? This is in the middle. 225. This one's 3 pi over 2, 270, but it's at 0, negative 1. 7 pi over 4, 315. So you can use your little circle to help you. I'm going at the halfways and my quadrantal angles. Okay, so on the note packet, want you to go back through and label 0, 90, 180, 270. Oops, I forgot my 360. Then go back through and do your pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Then what I want us to do is I want us to go do the 30 degrees around the circle. Are you guys caught up? I'll wait. All right, so if I'm at 30 degrees, that's pi over 6. And then over here, so watch this, I'm going to go do my 30 degrees. If I'm 30 degrees away from 180, that's 150. And here's a beautiful connection to what we talked about yesterday. If I'm at 150, that's 5 sets of 30. That's 5 sets of pi over 6. So I don't want you memorizing it, I want you reasoning it out. Now if I go into the third quadrant and I'm 30 degrees away, how many degrees is that? 210. 210 is 7 sets of 30. So it's 7 pi over 6. Now let's go 30 degrees away in the fourth quadrant. How many degrees is that? 330, and that's 11 sets of 30. Now let's go do the 60s. So here's 60 degrees and pi over 3. All right, if I go in the second quadrant, and you're going from the x-axis, okay, you're not going from the y. If I'm 60 degrees away from 180, how many degrees is that? 120. 120 is 2 sets of 60. So it's 2 pi over 3. Now let's go in the third quadrant. How many degrees is that? 240. And how many sets of 60 is that? 4. That's 4 pi over 3. Then let's go in the fourth quadrant, and if I'm 60 degrees away from a full rotation, how many degrees is that? 300. 300 is 5 sets of 60. Now we're going to come back to this, okay? We are going to come back to this and fill out more numbers, but for now, we've got all the angles labeled, and we've got the 4 quadrantal coordinates, 1, 0, 0, 1, negative 1, 0, 0, negative 1. Something I want you to write down off to the side, something you need with your unit circle is you need to know that every pair, x comma y, is the same thing as cosine theta, comma sine theta. And the other thing you need to know is tangent is y over x or sine theta over cosine theta. These are critical pieces of information to help you be able to evaluate any trigonometric function. All right, so in Roman numeral 2, recognize the domain and range of sine and cosine functions. So let's start with y equals sine x. And we know know from last year that the period length of sine is 360 degrees, or if I'm going to pop it in radians now, that's 2 pi. And I want you to go ahead and make 4 ticks on the left, because I'm going to segue this back in a little bit. So when I go to graph sine, here's a cool connection. If you look at the unit circle, and it's x comma y, and the y is sine, what's the sign of 0? 0. Okay, so sine starts at 0, goes up at pi over 2 is 1. So I'm using the unit circle here to graph. And then you continue the pattern on the left. Okay, this is going to be important to be able to see something. So the domain is all real numbers, and the range is bracket -1 to 1. And if I want to graph y equals cosine x, again, the period length is 360 degrees, or 2 pi now. In PreCalculus, we work predominantly in radians. So when you go to do cosine, I look at my unit circle, and the cosine of 0 radians, or 0 degrees, is 1. So you start up here at 1, pi over 2 is 0, pi is -1, 0, and back up to 1. And if you continue the pattern on the left, it looks like this. And again, the domain and the range are the same for sine and cosine. We will graph heavily next week, but I wanted to just kind of plant the seeds of bringing it back in your brains and connecting the graph to the unit circle, okay? And it's like the opening background part about calculus is that we take the graph and it's like you're just going around and around and around on the circle instead of plotting it the other way. It's kind of cool. All right, so in example 1, it says find the 6 trigonometric values of theta at pi over 2. So what I want you to do, so we're going to do the sine of pi over 2. So I want you to look at the circle, and I want you to go find pi over 2. Okay, look at the circle at the top of this page. Go find pi over 2, which is 90 degrees. And what would be the sine value there? I just heard it. What was it? Sine of pi over 2. It's 1, right? So then, if you want to do the reciprocal is 1 over 1, which is just 1. The cosine of pi over 2, okay, just in case I'm losing somebody here, let's go back up here. Here's pi over 2, guys, and the reason why I said write this down, the x values are cosine of the angle rotation, the y values are the sine of that angle rotation. So the cosine of pi over 2 would be what? 0. Then the reciprocal, secant, is 1 over 0, which is undefined. Tangent pi over 2, okay, and again, this is why I had you write this down, because you're going to sit there and say, well, around the circle it's sine, cosine, how do I find tangent? Well, we wrote this down. Tangent is sine over cosine. So that's 1 over 0, which is undefined. Then cotangent pi over 2, you take the reciprocal, which you would flip to make it 0 over 1, which is 0. All right, now you guys try example 2. Use your unit circle above and find the 6 trigonometric values of theta at pi. So sine of pi is 0. Cosecant pi would be 1 over 0. Now you can't leave 1 over 0 on a quiz or a test answer blank. You need to go one step and say that's undefined. What'd you guys get for cosine pi? Negative 1. Now secant pi is 1 over negative 1, which is negative 1. Tangent pi is sine over cosine, which is 0. And cotangent pi then would be the reciprocal, negative 1 over 0, which is undefined. All right, when you're ready, flip the page. And Roman numeral 3 says find exact values of the trigonometric function at pi over 4. So I want to refresh your memory here. In a 45-45 right triangle, you can use 1, 1, radical 2. And we're going to go ahead and do the 30-60 while we're here. In a 30-60 right triangle, it's across from 30 is 1, the hypotenuse is 2, and across from 60 degrees is radical 3. This is some geometry review. I know we looked at it again last year in Algebra 2, so this is 3 years on your special right triangles. So let's look at the sine of pi over 4. Pi over 4 is 45 degrees, so you're going to use SOHCAHTOA. SOHCAHTOA from 45 degrees is 1 over radical 2. Well, that simplifies to radical 2 over 2. And you can rationalize or not rationalize the denominator, but if my directions say rationalize the denominator, then you need to. Otherwise, you know, sometimes it's okay to leave it 1 over radical 2. You need to be able to recognize it either way. All right, then cosine pi over 4. Cosine pi over 4, adjacent over hypotenuse, 1 over radical 2. And then tangent pi over 4, TOA, is 1 over 1. Yeah.
To find out which angle is theta, is it like you put it on the unit circle? Is that like what you were doing?
Yes.
Okay.
Yeah, and that's what we're gonna go back and finish it up. Yeah. All right, so we're gonna pause here, and I want you to flip back to our unit circle, okay, in the note packet. And I went ahead and wrote it on the side chalkboard so we can see it. And yeah,
For the last problem, which angle were we using as theta?
you could use either. Because you get the same thing. Look, so if this is 45, 1 over radical 2. If I do 45 here, 1 over radical 2. It didn't matter.
Wait, so from 36 to 90,
It does matter, okay? So like if I want 30, so in the 45, 45, it didn't matter because they were both or 45s. But when I do a 30-60, great question. So it does matter. If I want the sine of 30, that's 1 over 2. But the sine of 60 is radical 3 over 2.
How will you know which one to use?
It'll be given, yeah. Yeah. So let's go back here to the unit circle. And do you remember? So I need you guys to really kind of focus and lean in with me here. If every x comma y goes cosine theta comma sine theta. So if I want to figure out the cosine, so here it's like it is given. We're going to go around the circle, okay? So if I've got 30 degrees and I put it on the side chalkboard. So if I go over here to my drawing and I have 30 degrees, cosine, SOHCAHTOA, is adjacent over hypotenuse. So cosine 30 is radical 3 over 2. And if I go to do the sine of 30, that's 1 over 2. So what I want you to do is I want you to label an ordered pair beside the 30 degrees comma pi over 6 spot. Then, when I go to do the 45 degrees, that's the one, I mean, you have to pick one, okay, you do have to pick one, but it doesn't matter which one you choose. If I pick 45 degrees, sine is 1 over radical 2. Cosine is still 1 over radical 2. Rationalized, that's radical 2 over 2. Then as I come around to 60, cosine of 60 is 1/2, and the sine of 60 is radical 3 over 2. So whether you saw this last year as a unit circle or not, it doesn't matter. We're seeing it now together, okay? So the nice thing about the unit circle is you just need to know your first quadrant. If you know the first quadrant, you can get your sine, cosine, tangent of anything anywhere else on it. And let me show you how. What you have is the circle has symmetry. So if I have this here, it reflects over. So when I'm 30 degrees away, I'm 30 degrees away. So I'm going to have this ordered pair here. However, and this is a really, really, really cool connection, is every point is an x comma y, right? When I go left, what happens to the x values? They're negative, but when I go up, the y values stay positive. Let me say that again. This is really important. So I'm going to use reflection to get to the other spots. But I have to pay attention to when I go left, my x values are negative. So watch how I'm going to reflect. This is going to be negative radical 3 over 2 comma 1/2. My 45s are the negative radical 2 over 2 comma radical 2 over 2. And up here, it's negative 1/2 comma radical 3 over 2. Now, we're going to do symmetry again. And we're going to take the second quadrant and we're going to reflect them down. Well, what happens is I'm still left, so my x's are left, but I'm going down. So what's happening to the y values? They're going down and they're negative. So watch, my 30 degrees away are the same. So this is going to go negative radical 3 over 2 comma negative 1/2. The 225 is negative radical 2 over 2, negative radical 2 over 2. At 240, it's negative 1/2, negative radical 3 over 2. Then the last quadrant. You can either reflect first quadrant over or third quadrant over. You choose. But here, I'm going to the right, so my x is positive and my y's are negative. So this one's going to be radical 3 over 2 comma negative 1/2. Radical 2 over 2 comma negative radical 2 over 2. And 1/2 comma negative radical 3 over 2. Now on Thursday, I'm going to show you a different technique that you don't have to use the unit circle at all. and we can still come up with them and come up with them rather quickly. Alright, so now our unit circle's done. You need to make sure that you remember that every x comma y is cosine the angle of rotation comma sine the angle of rotation. And tangent is sine over cosine. If you know that, you can do everything. Alright. We good? Got it? Alright, now I want us, before we flip back, I want you to look at my sine graph and my cosine graph. So I'm crafty here with how I've set this up. If you look at your paper on your sine curve, I want you to take your paper and I want you to turn it upside down and look at the sine curve, and what do you notice? If you take your paper and flip it completely upside down, it's the same, right? That's called origin symmetry. Now, look at the cosine graph. If you were to imagine folding the graph on the y-axis, what happens to this cosine graph? It matches up, right? That's called y-axis symmetry. So, now let's flip back to where we were, which is Roman numeral 4. A function is even if f of negative x equals f of x, and it's odd if f of negative x equals negative f of x. So if you look at y equals x squared, okay, y equals x squared, this is an even function because it's symmetric, and I'm going to use a little abbreviation here, with respect to WRT, with respect to the y-axis. And we talked about this last year in Algebra 2. Yeah.
We can go over this more. It's kind of a lot of information.
It is. We're going to spend 2 days on this. Yeah, we're not finishing the packet today. No, but I strongly recommend that you spend time, read back through this once or twice before tomorrow as far as we've gotten, because you're absolutely right. This is a lot of information that we're taking in, but it should be the majority of its review. We're just trying to get it back in our brains. So y equals cosine x is even, and we just looked at that on the graph, because the cosine graph is symmetric with respect to the y-axis. So what we're going to learn is even functions, f of negative x equals f of x. So what I have here for cosine, cosine of negative x equals cosine x. That's kind of cool. Then I want you to look at y equals x cubed. If you remember from Algebra 2, we graphed y equals x cubed. And if you take your paper, once you sketch x cubed and you turn it upside down, this is symmetric with respect to the origin. And it's odd. Well, y equals sine x is odd. And what we know about odd functions is that f of negative x equals negative f of x. So what I have here is the sine of negative x equals negative sine x. And then tangent is also odd. And tangent looks like this if I do a quick. And we'll graph in detail end of next week. But for now, so tangent and sine are odd, cosine is even. The reciprocal functions go with their partners. So if I look at example 4, it says find the value of each trigonometric function. So cosine is even. what that means is f of negative x is equal to f of x. So the cosine of negative pi over 4 is the same thing as the cosine of pi over 4. So you can either use the unit circle or you can use your 45-45 right triangle. Either is fine. And I left on the chalkboard my 45-45 so we could easily use that. So what's the cosine of pi over 4? Radical 2 over 2. So the cosine of negative pi over 4 is the same thing as cosine pi over 4, so it's radical 2 over 2. All right, tangent is odd. So that means f of negative x equals negative f of x. So the tangent of negative pi over 4 is equal to negative tangent pi over 4. All right, well, what was tangent pi over 4? 1, and so that's negative 1. Sine is odd, so the sine of negative pi over 4 is equal to negative sine pi over 4. And so sine of pi over 4 is radical 2 over 2, so that's negative radical 2 over 2. All right, flip it. We're going to get to example 6 today and stop because our brains are reaching full capacity at this point. So let's get to Roman numeral 5. It says, many relationships exist among the 6 trigonometric functions. These relationships are described using trigonometric identities. Trigonometric identities are equations that are true for all real numbers for which the trigonometric expression in the equations are defined. So we've already talked about all of these. The sine is the reciprocal with cosecant. Cosecant is reciprocal with sine. Cosine is reciprocal with secant. Secant is reciprocal with cosine. Tangent is reciprocal with cotangent. Cotangent is reciprocal with tangent. The quotient identities, tangent is sine over cosine, and cotangent is cosine over sine. So let's look at example 5. If I have sine x is 2/5, and cosine x is radical 21 over 5, find the remaining 4 trig functions. Well, what I like to do is I like to start with the reciprocals because those are the easiest. So if sine of x is 2/5, what's cosecant x? 5 over 2. Secant x is going to be the reciprocal. So be comfortable if I leave it as 5 over radical 21, or if I rationalize it, you should be able to know, no matter which way you wrote your answer, like that you've done it correctly. Now, how am I going to find tangent? Sine over cosine. Yeah, sine. So I'm going to take 2/5 over radical 21 over 5. So that's going to be one of the most common questions I'm going to receive is, how do you do tangent? How do you do tangent? How do you know that? Tangent is sine over cosine. So that's 2/5 times the reciprocal. The 5's cancel, and I get 2 over radical 21. I'm going to pause and flip that for cotangent because that's a nice looking answer. And I can rationalize it back up here if I need to. All right, try example 6 on your own. if you have sine x is 2/3 and cosine x is radical 5/3, find the other 4. All right, cosecant x, I got 3/2. Secant x, I got 3/radical 5 or 3 radical 5/5. To do tangent x, I took sine over cosine, which is 2/radical 5, which I like to pause and flip it because that's going to turn out nicely, and then rationalize. All right, we're going to pause there. And I gave you